All right, so this is Unit 4, Lesson 2. Unit 4 is Applications of Differentiation. Lesson 2 is Interpreting Motion from Position Graphs. So what we're going to learn is just that, uh, understanding motion from position graphs, and then some words we can use to describe these motion graphs. So a couple of those words are concave up, concave down. A curve is called concave upward, basically on these blue intervals. So you can kind of look at them like a cup that points upward. Technically, concave upward is anywhere where the curve is above its tangent lines. So if I drew the tangent lines anywhere where it's blue here, tangent lines would always be below the curve, or the curve would be above the tangent line. Concave downward, marked in red on 3 places on this curve, is anywhere where the curve is below the tangent line, or it kind of makes a cup downward. And so these concave downward and concave upward intervals are connected by what's called inflection points. Inflection points technically would be when the tangent lines switch from being above to below or below to above the curve. Okay, so if we're looking at graphs and the derivatives, or velocities, derivatives, acceleration, anywhere where the tangent line has a zero slope, so it's a flat tangent line on any position graph, its derivative graph would be an intercept. So again, we have a zero slope tangent line, so we have another intercept. And then the inflection points on our motion graphs would be the steepest point in that local area. So we have 2 inflection points. Inflection points would show up as a minimum or a maximum value on its derivative graph. So again, flat line would be intercepts on the derivative graph. Inflection point would be the min or max on, or local min or local max on derivative graph. Okay, so if we're looking at a position graph, our position is getting closer, stops for a moment, gets closer, or moves to the left, stops, moves to the left, same thing. And then it stops and it goes further away or moves to the right. Stops, rests, moves closer or to the left. So on what interval is the object moving to the right? Well, it's moving to the right as this position graph goes up. So from 9 to 13, that means the other intervals are all the times when the object is moving left. So from 0 to 9, and then from 13 to 18. Any time where we have a flat tangent line slope equals 0, 5, 9, 13, those are all points where our object stops moving for a brief point in time, or the instantaneous rate of change is 0. Okay, so intervals where the acceleration is positive is any concave upward. So positive acceleration means we're slowly moving, pushing our graph towards the positive velocity direction. Notice it's still a negative velocity, but it's becoming less negative. And then concave down is anywhere where our acceleration is negative. So even if it's a positive position, we're pushing our velocity towards the negative direction. This whole interval. Okay, and so thinking about acceleration from position graph, that's what we're going to say. Acceleration is increasing when velocity and acceleration are both in line. Our acceleration is decreasing when they are at odds. So one's going up, one's going down. So from 0 to 5, our position is all positive. Our velocity is all negative, but it's concave upward. So our velocity is negative, but our acceleration is positive. Concave upward means acceleration is positive. So because these signs are at odds, this would be a decreasing acceleration interval. From 5 to 7, we're concave down, so we're decelerating, or acceleration is negative. And then we're also, our velocity, all of our slopes of our tangent lines are negative, so we also have a negative velocity. So our velocity and our acceleration from 5 to 7 are in harmony, so this is an increasing acceleration interval. And then we have an inflection point, so that means from 7 to 9, our acceleration switches. Our acceleration is now, concave upward is now positive acceleration. So from 7 to 9, we have positive acceleration negative velocity, so this is decelerating. And then from 9 to 7, we still have positive acceleration, but now we have positive velocity as well. Or we have tangent lines with positive slopes, in other words. So now they're in harmony, so from 9 to 11 would be increasing acceleration. And then from 11 to 13, our acceleration is decreasing now because it's concave down. Velocity is still positive because we still have positive slopes of tangent lines, so now we're at odds. So this is 11 to 13 is a decreasing acceleration interval. And then from 13 to 18, we still have a negative acceleration, but now we also have a negative velocity. So from 13 to 18 is an increasing acceleration. All right, so we're talking about some words to describe motion of position graphs. Don't worry, you're not going to have to do any more crazy bunny graphs. That evil bunny.